square base pyramid is 8,000 cubic centimeters. Determine the length of the base if the height of the pyramid is 0.9 meters. Okay, so watch out. That's meters, that's centimeters, so 0.9 meters. Meters on the bottom, 1 meter is 100 centimeters, so that will be 90 centimeters. That's what we're going to want to use for this number, is 90 centimeters. I don't draw pyramids well. There you go. But I do know that this is B, and this is B, and that's H in there with a little 90 and a slant height. But we're dealing with volume, right? So, formula. Volume of a pyramid is 1/3 the area of the base, right? Which is 1/3, let's call this B squared H. Okay, volume is 8,000. 1/3. Our base is, no, our height is 90. Ah, erase. Back to the pen. B squared times 90. Okay, determine the length of the base. Alright, so we're going to multiply by 3 first, right? Get 24,000 equals 90b squared. So b squared is 24,000 divided by 90, and b is the square root of 24,000 divided by 90. Calculator on, clear. Second root 24,000 divided by 90, enter. 16.33, round your answer, so 16b is 16.3 centimeters. How do you know if you're right? Try it with 16.3. Go back to here, put in 1/3 16.3. You notice that's going to be a little small, so we're going to be short squared times 90, and we should get 8,000, right? Actually, it's going to be a little under because it's 16 point, this, but close enough. That's the look back, right? I can go back and check and say, yeah, okay, good. Okay, so there's the length of the base, so we get the length of the base of the pyramid is 16.3 cm. Determine the surface area of the rectangular pyramid shown, rounded to the nearest tenth. I hate these. There's so much work to do. So this is 6 from here to here. And we have another slant height, right? We got this guy. And this will be 4. And we'll call this S1, and we'll call this S2. So there are going to be 2 faces with S1, 2 faces with S2, plus the square base. So first thing we're going to do is we've got to get S1 and S2. So S1 squared will be 6 squared plus 10 squared, right? And I'm going to start getting efficient here, right? That's the root of 136. S2 squared is 4 squared plus 10 squared. So that's the root of 116. The surface area is going to be 2 times, okay, 1/2. All right, if that's S1 and this is B1, that's B2, okay, so it's going to be B1 S1 plus 2 times 1/2 B2 S2 plus B1 B2, right? So this 2 takes care of this face and this face, and this 2 takes care of the front and the back face, and this B1, B2 takes care of the rectangular base. Okay, 2 times a half is 1, so it's just B1, 8, times S1, which is root 136, plus 2 times a half is 1, so it's 12, root 116, plus 8 times 12. Nearest tenth. Alright, let's do it. Clear. 8 root, again, exact, no rounding, right? Then move over. Plus 12, exact, 116, do not round until the end, plus 8 times 12, enter. It disappeared. 318.5. 318.5 centimeters squared. Yay. If this had asked for lateral surface area, then we would not include this, right? Lateral would just be the faces, but no lateral. Determine the surface area and volume of the composite object shown. It's like our ice cream cone, only somebody flipped it over. So this is a Bosu ball wearing a birthday hat. Round your answer to the nearest hundredth. So in this case we have the lateral surface area of a cone. We have the lateral surface area of a hemisphere. Aren't volumes so much easier? So surface area lat cone plus surface area lat hemisphere. Formulas. Okay, so the lateral surface area of a cone is pi r s. We don't have s. This is s. S is equal to, look, just go in there, 12.6 squared plus 9 squared plus 1. I don't remember the formula for the so I'm just going half of the area of a sphere and not adding on that, right, which is 4 pi r squared. Okay, plug in pi, radius 9, root 12.6 squared plus 9 squared. Half of 4 is 2, so 2 pi 9 squared. Plug it in, work it out. Second pi times 9, you don't even need the times. Times, you don't even need the times. Root 12.6 squared plus 9 squared. Move out, get out from under there. Plus 2 pi 9 squared. Enter. 946.74. 946.74 meters squared. And the volume. Okay, volume easy actually, right? So V is equal to V cone plus VHS hemisphere, not VHS, the tapes, but you don't even know what that is these days. Pretty soon DVDs won't even exist. Okay, volume of a cone is 1/3 pi r squared h. Volume of a hemisphere is 1/2 of 4/3 pi r cubed. Substitute 1/3 pi 9 squared 12.6. Half of 4/3 is 2/3 pi and 9 cubed. 9 cubed. Excuse me. Calculator. Clear. It's like defibrillating. Clear. Pi 9 squared 12.6. Well, it's kind of ugly, but it actually works, right? I mean, it's got to square the 9. I mean, order of operations, it's got to do the brackets, it's got to square the 9, and then it's going to go through and multiply, right? And then plus, so it's got to do the brackets. 2/3 and then pi and then 9. Cubed, right? So you'd use this, the caret, for cubit, and hit enter it. And we get 2595.58. 2595.58 meters cubed, volume, right? Units, meters, meters cubed, don't lose half marks. Convert 6.7 kilometers to centimeters. Lots. It's lots. Okay, we want conversions, right? We want kilometers on the bottom, and we can only go to meters, and we know that there are 1,000 meters for 1 kilometer. We want it meters here, so these cross off, these cross off, and a meter, and we need centimeters, that's what we're aiming for, is 100 centimeters. So 6.7 times 1,000. This is actually easier to use the calculator this way than the actual calculator. 67,000. 67,000 centimeters. 980 centimeters to feet and inches. 980 centimeters times. So do I want to convert that to feet? I mean, we could do it to feet and then do it to inches. You know, I'm going to go straight to inches. So I want centimeters on the bottom and inches up top. And I know that 1 inch is 2.54 centimeters. So this will be equal to, slide. Yeah, okay, it's getting late. 980 divided by 2.54. So 385 point something, 826 inches, right? That's how many inches we have. So what do? We divide by 12. Okay, divided by 12 equals. So there are 32 feet. If we get to 0.157, right? Here's what I do now. I say, okay, what's 32 times 12? So that's 384, right? That takes care of 384 of these, and we have 385, so we've got 1.8 inches left. And very rarely do you see decimal inches, but here you do. Because very rarely are there rulers with decimal inches. You look at rulers, it's like 16ths, and go imperial. If the speed of light is 299,792 meters per second, determine the speed of light round nearest mile per hour. Oh, okay. Well, this time, you know, I've been a little sloppy in some of the conversions, like kilometers per hour to miles per hour, just saying let's change kilometers to miles. But now we've got meters per second. 4, 5, 8. So you know what? I want to make life easy on myself. Let's just convert the meters to miles. Do we have a conversion for that? I don't know if we do, but I'm going to make one up. Let's go meters to kilometers. So 1 kilometer is 1,000 meters. And I do have one for kilometers to miles. Kilometers and miles. And the one I remember is this, 1.609 is 1 mile. So that's going to be, sure, 299,792. 299,792,458 divided by 1, 1, 2, 3. Hit enter. Do multiple divisions. Just easier to hit enter. Divided by 1.609. So that's 186,000. I actually know this number from a long time ago. 300. It's not exactly right. 322. Remember, we're just going to leave this number in our calculator. 0.2237, and that's in miles per second, right? So let's go to miles per hour. So here, let's do another conversion. 186,322.2237. Just remember, we're going to leave this in our calculator. Miles per second. And what I want to do is I want to get rid of the seconds. So I got to put seconds up here so they'll cancel off. And I want hours here. And I know that there are 3,600 seconds in 1 hour. So I'm going to multiply by 3,600, and I will be left with miles per hour, right? 1 hour is 60 minutes, and 60 minutes is 60 seconds, so 6 times 60 is 3,600. And so we're going to multiply times 3,600 and get, wow, okay, let's see here, that's thousands, 670 million, 670 million, 760, 006 miles per hour. Rounding, right? We're rounded to the nearest mile per hour because that's what it asked us to do, and we did. And let's go on. Scale on a map is 1 to 500,000. So remember that means 1 unit on the map is 500,000 units on the ground in real life. The distance between 2 campsites on the map is 3 7/16 inches. Then determine the actual distance rounded to the nearest mile. So what we're going to do is we are going to take 3 7/16 and multiply that by 500,000, because in real life that's how many inches there will be on the ground. Okay, clear? So 3 plus 7 divided by 16, and enter, okay, times 500, 1, 2, 3. So there are 1,718,750. 1,718,750. 1,718,750 inches, and we got to convert that to miles. So 1,718,750. And don't worry, this number's sitting in our calculator, right? Inches, feet, 1 foot, 12 inches. Feet, miles, 5,280. Okay, so we're going to divide by 12, then divide by 5,280. Divided by 12, divided by 5,280. Rounded to the nearest mile, 27 miles. Oh my God, it's done. Okay, so that's not it, right? Obviously, it's been a pretty big unit. You need to review lots of stuff. Hopefully, you've done lots of homework. You've got lots of practice. You feel that you can do any of the questions. And I guess we'll find out on test day. Okay, so that's it for review.